Hello, welcome back to my channel. We're going to be talking data as we normally do with these videos. And today we're going to be talking about operational data stores, also known as ODSs. It's a term that gets thrown around quite frequently. I don't believe it has a real discrete definition. You can look up what it says on Wiki and other sources and cull your own information from them. So we'll take a look at my vision of the operational data store, let you understand what it is, why it is, what to be concerned about, and then we will design a quick little process flow to populate an operational data mart, as they call them, which is what you put dimensionally into a data store. And again, what you put in your data store depends upon how it is that you wish to pull it out and how you want to store it. Given my devices, I find the most efficient way to store the data and the easiest way to query the data is through a dimensional data model. And so that's what we're looking at as the target. So let's continue on and talk about an operational data store. It's called an ODS. Don't we love acronym in the data world? But more importantly, if I expand out on some of the terse definitions of an operational data store and talk about what it is that I have built in the past, and that it is a single subject matter orientation. It's not designed to do a whole lot of different things. It's designed just to give you the ability to populate a report or dashboard, allow some investigation. It's called operational because typically you're looking at operational data that changes quite regularly. Again, if you're looking at your HR department, you don't change people every single minute. But if you're looking at sales, that'd be an operational data store, because sales, if you're in a real robust business, these change regularly. You look at web servers and web messaging, and that's typically the two that I built in the past is either for sales and orders or through the operational side of a web service or other application to figure out what the heck is going on behind the scenes. It should be near real time, and I would typically put the real time in quotes. In this case, I did not. There is no such thing as real time data stores. Data is never stored outside of the transactional system in real time because it always has some slight delay associated. So I always tell people real time data is a fallacy. Let's talk about near real time, and what does that mean to you? How frequently do you need this data to be pulled into your operational data store to see in your reportings? 5 minutes, 15 minutes, 20 minutes, 4 hours, half a day, 2 days. Again, so if you begin to stretch out of the minutes, you can look at populating every hour. That's something that a data warehouse can do within itself. It doesn't have to necessarily go into that operational data store. But to get those things that are reflective upon 5 or 15-minute turnaround, you need it to be very small and nimble, because you can't do a lot of data processing. You can't do a lot of data validation. You need to get the data in and get it put and stored so it can be reported. You also look at what they call atomic level data. You don't want to do roll-ups, summarizations, contrasting, and things like that. You want that to be done in the reporting tool. What you're storing simply is the data that you see. You're doing a little bit of cleansing and blending to make it palatable to the reporting system, but you're not doing a lot other than that. It is not integrated or possibly loosely integrated in your data warehouse. You might pull a couple of static tables. In my data mart that we'll be looking at today for the ODS, we actually use the date dimension because that's something that is sitting there very easy to use, but we won't be looking at integrating, like for example, as we talked about in the past, the customer master data management part of the data warehouse. You don't need to do that. You want to just bring something like that in directly and use what you have and let the data warehouse worry about it later, because the data might flow into the data warehouse. It's not necessarily going to have to. Data warehouse might just simply pull it on its own. So what are we trying to solve with the ODS? Well, the example we have is a lot like one that I built many years ago for a company that was providing some highly volatile data stores, and they found out that their web system started slowing down and inexplicably, and they decided to blame it on the database. Once we proved it wasn't a database, we had to look at there's something wrong with your application. We just don't know what it is because you don't know what your application is doing. So the same thing sort of happened here at Daisy Hill Puppy Farm. You remember in the previous video we talked about the rescue puppies, and everything was great. They expanded it out and made it bigger and more robust. They added more kennels from a regional standpoint and shelters into it. Everything was going great until suddenly the website started experiencing delays, drop session, error messages. People started complaining about the performance, and the application guys didn't really know what it was that was slowing them down. Typically this happens because there's a layer in the middle of your web service and the database called an ORM, which is the object relational mapping. And that is basically you send a message to the ORM. And this is, again, I'm not a great development guy, so you're going to have to take this as third-hand knowledge. If you want to know more about this, please look into it. But this is just simply the example we're trying to use. And that is the fact that you send a message, it goes ahead and translates that into a database query or queries and then returns the data back to you. And so this is what was slowing down. And so what we decided to do for Daisy Hill was to build an ODS so that we could look at the server logs that were dropping out information about every message that was being sent to the ORM, so they could then consolidate what was happening, how often things were happening, and where the longer message returns were, as well as if there was a reported slowdown, what was happening during that period of time. So something that needed to be very quick and very nimble, very simple and direct forward. Part of it is that if you just simply have a single web server or something very small, you're not dealing with a lot of data. But the example that I used for a previous organization, they had 25 web servers that were all kicking out messages, and we had to process them very quickly and get them into the database without having collisions. So let's go ahead and talk about what it is that we are going to build. Our starting point for this endeavor is the web log record. This is a text length and delimited file. Put it out this way as far as a description in more tabular format, so we know that we're getting in that record. They're going to send us a log file every 5 minutes. We need to process it within that 5 minutes. That is our requirement to deal with it. And again, fortunately, it's not a lot of data, but it's coming quite frequently. So we've got to be very efficient and nimble so that every log file is processed within that 5 minutes. We begin to stack up log files. We'll have to worry about collisions. And again, if we have the time, we can design around collisions. And depending upon the tool that we use, we can deal with the collisions different ways. Always recommend that you look at what resources you have available and get someone to help you build this out. One of the systems that I put together, actually, we did not have to, from the ODS standpoint, move the data. We got the application systems management team to go ahead and, once a log file was closed, would then ship it over to our server. And then once the file was shipped in the server, it would kick off a process to notify us to begin automatically the processing of that file. So therefore, it was quite quick and dynamic that way. We also used the database to deal with locking issues, so we didn't run into any kind of collisions along the way. So it worked out between all three of those systems, the ETL tool, the systems web service, and the database, to build a system that gave us a good solution, so we didn't have to stress about all those things. But in this case, we get a request ID. This is a overloaded field. It has a lot of information in it. Turns out we really don't need that request ID. It's sort of built so that it can keep track of the sender and receiver. What important is the server ID. We only have one server right now within Daisy Hill, but it's nice that they gave it an ID. We have the username that made the request that was using the website. Again, this is not something that we need in our nimble world because that's immaterial to looking at how well the system is performing. We do, however, need the request name so we know what message was being sent. And we have a receive timestamp and a response timestamp, so we know when it happened, and then we can calculate how long it took to do it. And we have a status code as to whether it errored out or was completed or something else occurred, just to help clean up some of the querying performances that we are doing. So we now identify our performance requirements, because this, again, depending upon how sophisticated or how large your requirement is, you will need to understand maybe some additional processing that you have to do. In our case, it's very small. They do want it every 5 minutes, which is pretty quick, but we only have one server and there's approximately 100,000 records in each file. So we don't have to worry about concurrent read and write access going on because there won't be very much collision happening. And if we cannot meet the requirement of processing a log file in 5 minutes, we will have to worry about data locking, but pretty much every tool that I would use to do this with, this is very doable, so we are happy to do that with. Take a quick look at our target. Again, this is just a dimensional model, and you'll see how simple it happens to be. We have the server ID that we're going to be saving in a dimension. Note that we put a server name in here. The server does not have a name coming through the data log, but this is somewhere that we can update this on the fly later on just to go ahead and keep things from a reporting standpoint a bit easier to do. We're going to reutilize our date dimension, and we're going to go ahead and create a message dimension and a status dimension. This one shouldn't change very often. Over time, we should fill up the message dimension as well, and then it should become quite static, but this gives us the ability to do our reporting a bit more simple. And then obviously we create our fact table, which is related to these dimensions. Well, one quick change in here. Now that I see this, we do not have a primary key for any of this. Let's go ahead and drag this out. Trying to keep this in alphabetical order. One further down, it comes alphabetical. So we do not have a primary key in this because there's lots of messages that all will, to agree, look the same. We could use this rescue time to make them differentiated, but we still might have multiple ones in here as well. So basically this fact table does not have a primary key. So cleaning it up is just simply going to be based on targeting. Every record is going to be inserted. That also makes the processing pretty easily. So what we need to do, the data coming in, is to get this request date and the other 4 dimensions rationalized, calculate the response time in seconds. And for this usage, I tend to like to go ahead and, rather than have a time field in here, to go ahead and move the time field or translate the time field into an integer. You have a choice as to whether you want to do this as seconds from midnight. In the case of what we're trying to do in order to get reporting done more easily, we just want to translate it directly into the 24-hour clock, so that if it's 1 o'clock, 1:05 in the afternoon, we would make it 13:05 for the integer, etc. That allows us to go ahead and not do the math, because that must be done from a time standpoint, but it does allow us to do the querying much more easily. And so we can deal with that as well. So that is the data model without going into too much depth in it. But what we want to look at now is what is the data flow? How do we get this done efficiently in order to meet the requirements? So I basically went to my favorite design tool, which is Visio. I have my own icons that I use in here, as well as this is data flow diagram shapes. I pretty only use one of these out of here, but it's nice to start with them. And again, over the years, I have developed my own set of favorites that we would like to use. So first of all, we want to identify, and we'll just do a cut and paste from another object I have floating around out here, which is we want to identify all of the tables or other files that are going to be going in on this. So what we have to deal with here is we have the log file coming in, and in this case what I would build would be a way to store this inside of the database. A couple different ways we can do this, naming conventions, etc. This is again a design and not an implementation, so we let that to the hands of the developers. But we also want to populate the server dimension, the message dimension, and the status dimension coming out of that data. And we want to use the date dimension to match it up as well to make some of our reporting easier and some of our analysis. And then finally, what we really want to get out of this is the request fact as well, which is a combination of all this data that we put together. So from a data flow standpoint, what we want to do is we want to go ahead and have a couple of processes. One process is going to be to load the log file from the server. We also then want to populate the server dimension. And again, use the tools that are available to you. How is it that you want to accomplish this? Well, whichever way happens to be easiest and what tools you have available to you. If a tool is not being nice and to give you the functionality that you want, and you might want to blend together a couple of different tools. We also want to populate the message dimension. And then finally, we want to go ahead and populate the status dimension. Now these are pulled out here in separate ones because this is the way that we want to process to get it done as quickly as possible. Simply go ahead and kick off the process and the flow that will allow that server dimension to be quickly updated. With any new servers in there, the message dimension and the status dimension, all of these simply will be inserts if they don't exist. If they do exist, we will just simply leave them alone. This gives very quick processing, not worrying about locking. Once everything is up to date, then we know, since all the data is there and available, it's very easy to match all that data up to the fact table that will be populating at the very end. From a data flow standpoint, all that we want to do next is simply to connect all of these together. So let's choose our connector. And so what we want to do is the log file flows into this process, and what flows out of it happens to be the log file itself. That log file flows into not only the populate the server dimension, but it also flows into the populate the message. From a processing standpoint, these can be done in parallel. They don't have to be done in serial. So if we have a good tool that will allow us to do that in parallel, all this can be done simultaneously and done very quickly. Once all three of these are done, once we have populated the server dimension, once we've populated the message dimension, and once we've populated the status dimension, oops, get this in the right place, makes life easier. There we go. Once we've done all of these, it's amazing how sometimes things just don't simply drop where you expect them to. Windows is wonderful that way. There we go. Now they're all connected together. So now we've created all three of, or updated and processed all three of these. Again, this can be done in parallel. Then what we want to do is to go ahead and begin to, we will populate the fact table by bringing in the server dimension. We'll bring in the message dimension. Trying to make this look a little bit prettier for you. Data error, I know it's not good to have data error in this process, but that's okay. And then finally, the third thing that will flow into this process is all of our dimensions. We'll do this through lookups or queries, depending upon the tool that you use. If you use an Alteryx, this is a real quick lookup after we have gone ahead and populated all three of these. So you don't want to use this data flow from the log file feeding into this population, but simply the three-dimension tables once they've finished. So you may need to do some kind of blocking and process waiting. Again, depends on your tool how this happens. Don't forget we also need our log file comes in as well, because this is where the lookups go. So this is one reason why I would store this lookup in the database, or to store the log file in the database, because I'll be using it multiple times. Makes it easy to not have to worry about it flowing. But again, if you use Alteryx, Alteryx can take that single flow and process it all the different locations. And then finally, we will also make sure we hook it up to the date dimension just to make our reporting easier. Once all of that flows into this process, as you can see here, keep things more easily to read. All of these tables that we've created and one that's already existing out there that we want to use, all the data gets put together, blended and cleansed, etc. And then it becomes very easy to go ahead and populate the fact table. So that all being said, this is the data flow that we processes. This is a very efficient way to go. We don't have to deal with each individual record doing all the work, but we simply do some aggregations and find out what we have to add through the dimensions very quickly, add them, insert them. We don't need to update them. We pull in the date dimension and we go with our fact table. Get that done in 5 minutes for 100,000 records. It is very easy to do, and then the reporting can stay fairly accurately and up to date so they can determine what it is that's leading them into the slowdown. There's our data mart. There's our data flow diagram that we see that we do to move that data into it. And as a quick summary, we want to go ahead and talk about what we did. You create an ODS for real-time data is required for operational reporting. Keep it nimble to meet reporting requirement. It's not integrated in the data warehouse. And please utilize any existing technology or infrastructure that makes it easier. You don't need to be all on it yourself. How are you going to get the log files over to your system? How are you going to kick off the job? Who's going to control that and see that it works and monitors? Use the systems that are out there. Use the best tools that you have available, whatever they happen to be, because the quickest and the most efficient ones are the ones that will get you the job done in time. So I hope that sort of leads you in the direction of what an ODS is, Operational Data Store, how you should not be afraid of doing it, and why you would recommend doing it in order to meet some of the business's needs. As always, please subscribe, drop me your comments, let me know whether this is you like it or not. Does it meet some of your needs? Have you found it useful? Drop me comments or an email. Let me know what else you might like me to talk about as far as any specific design issues and processing issues that you have within your data world. Thanks for watching. Have a great day. I will see you later.